so it's not that complicated. So when $100 grows by 7%, okay, so 7%, then we multiply by 1.07, okay?
Yeah.
So 100 times over 1.07, that's equal to 107. Now, if you multiply again by 1.07, so if it was simple interest, so let me just tell you something. Simple interest is a bit like the arithmetic sequence,
Yeah.
where it increases by $7 every year, for example. But if you have compound interest, this one is very similar to geometry. So let's say there is a maybe a stock price, okay? So you want to buy a company's share, and let's say you want to buy Apple share, okay?
Yeah.
Let's have a look at the company Apple's share over many years of Apple's stock price. So what year were you born?
2002.
2002. Let's go back to 2002. So if we go back to 2002, what month?
August.
August, okay. So you can see that in August, the Apple stock price was $1.12, right?
Yeah.
But now it costs $200, 241, right?
Yeah.
So over here in 2000, did you say 2002?
Yeah.
2002 August was like $1, right?
Yeah.
So over here, it was $1. Okay, so you can see that it's growing, right?
Yeah.
So let's see what happens if you invest $100 in the Apple stock in 2002, just $100, okay? Then by this time, it went by how much? 241. It used to be $1, but now it's worth $241. So if you invested $1, that'll grow to $241. So imagine investing just $100, then right now it'll be worth 100 times about 241, it'd be worth $24,000.
Yeah.
That's a lot, right?
Yeah.
So if someone invested $1,000, then it would be worth just $1,000. That's not that much, but it'll now be worth $241,000.
Yeah.
That's a huge amount, isn't it? That's a huge jump.
Yeah.
Now we can think about what happens. So that's over how many years? Over 18 years, right?
Yeah.
Now let's see what happens if you invest $100, and so if you invest $100, that becomes $24,000. About that much. That's actual historical result. That's what
Yeah.
happened. But let's suppose that this $100, there is another stock. So this stock Apple became so it became from $100 and then became 24100 over let's say 18 years. Okay.
Yeah.
Let's say there is stock pear, all right, or pineapple, whatever. And let's suppose that that's $100 also. You invest $100, but let's say that this one is going to increase by 7% every year. And let's see if that's better than the Apple share, okay? So what you need to do is just keep multiplying by 1.07. So that's going to be $107 the
Yeah.
next year. So this is year 2002. This is 2003. So if you just keep doing that, over 18 years, all you have to do is just 100 times by 1.07 to the power of 18. And that's worth 300 and, sorry, is that right? It's, let me just think about this. Why is it only that much? So it's only going to be worth yeah, only, it's not that much really.
Yeah.
330, how much was it? 337, 338. So it's not that much really compared to this one. You can say that, let me just think about this. So if you have 241 and then to the power of 1 over 18. Okay, so that's actually 35% every year. That's a lot of change. So Apple stock is worth about 35% growth every year. That's huge difference between that and that, right?
Yeah.
But anyway, if you have a simple interest, you have $100 and that becomes $107. Let's say it's 7%. The
Yeah.
interest rate is 7%. Then it'll be adding by the same amount. It'll be 114, okay? And then 121. So you see it's plus 7, right?
Yeah.
Plus 7. It's plus 7. I want you to compare that with the compound interest. You multiply by 100, this is 107%. So why do we do 107%? We want to do the original 100% and then the increase of 7%. We want to combine that together. So it's going to grow to 107, and then you keep multiplying by 107. Okay, 1.07, then you get 114.49, and then you multiply by 1.07 again. So you can see that it's a little bit more than the simple interest, right?
Yeah.
So which one is better, simple interest or the compound interest? Which one is better in terms of making more money? Definitely the compound interest, isn't it?
Yeah.
So do you think our banks like ANZ, Combank, things like that, do you think they apply simple interest on you or compound interest on you?
Compound.
We always use compound, so no one uses simple interest, okay?
Yeah.
Yeah. So when we are dealing with money, it's crucial that you understand that if you have 7%, that's multiplied by 0.07, okay?
Yeah.
If you have 107%, that's multiplied by how much?
1.0.
1.07, okay? If you have 200%, that means multiplied by how much? Just have to divide by 100. So you divide that by 100, divide that by 100, divide that by 100, then you get how much? You get 2, right?
Yeah.
So that's the really important idea. So let's go back to this question. We'll just do it bit by bit. So does number 1 make sense? An increase is 7% increase is made by using common ratio of. When they say common ratio, remember in arithmetic sequence, if you have like 1 and then you multiply by 2, then you get 2, right? And then 4 and then 8 and then 16. You recognize this as geometric sequence, right?
Yeah.
This is geometric sequence. And then you multiply by how much? 2. And when we learn geometric sequence, we let this figure equal to R, true?
Yeah.
R is known as the common ratio. And common ratio is what you multiply by, right? Multiply by. And that's equal to 2, okay? Make sense?
Yeah.
So here, if it's keep increasing by 7%, then you have to keep, in this case, the R is 1.07, understand?
Yeah.
Now, let's move on to the next question. triangular numbers are based on the pattern. So you see this one, there's 1 there. Here you have 3. Here you just keep adding 1 level, okay?
Yeah.
So the next level will be 5 more than this one, right?
Yeah.
So it'll be 15. And then it'll be 6 more than this one, will be 21, right? So this will be, this is 2 more than that. This is 3 more than that. This is 4 more than that, right?
Yeah.
So here you're adding +2, +3, +4, +5, +6, right? So if you do +7, then you get 28, etc.
Yeah.
So these are triangular numbers. Can you tell me whether this is arithmetic sequence or geometric sequence?
Arithmetic.
Well, not quite arithmetic. Because if it was arithmetic, then you would be adding by constant number.
Oh, yeah.
You're adding by 2 and then 3 and then 4, right? So if it was adding by 2 and then 2 and then 2, 2, 2, then that would be arithmetic. So this is actually neither. This is not multiplied by constant number. So if you multiply by 3, then you get this. If you multiply by 2, then you get this. If you multiply by like something else, like fraction, then you get 10. So it's not multiplication by constant term either. So this is neither. This is neither geometric. This is nor arithmetic. Okay.
Yeah.
Now the first 4 triangular numbers are 3, 6, 1, 3, 6, 10. The 6th triangular number is, well, that's pretty simple. First, second, third, fourth, fifth, sixth, right? So that's 21. Simple.
Yeah.
I'm going to move on to question 3. So Brian has 2 trees in his backyard. Every month, he will plant 3 more trees. The recurrence model for Tn, the number of trees in Brian's backyard after n months is. All right, so how many trees are there initially?
2.
2, so all of this is fine. T naught is 2. Now Tn plus 1 equals to something Tn. So they want to find out, this question wants you to find out the relationship between the number of trees in the previous month to the number of trees in the next month. Okay?
Yeah.
So every month he will plant 3 more trees. So this guy must be 3 more than this one, right?
Yeah.
So what would be the T1? That's after 1 month. How many trees are there after 1 month?
5.
5. Well, how many trees will be there in after 2 months?
8.
8. So this will be like 2, 5, 8, etc., right?
Yeah.
This will be like 11 and then 14, etc., etc.
Yeah.
So is this arithmetic or geometric?
Arithmetic.
Arithmetic, that's right. Arithmetic. Now, the number of trees has this formula. If you go back to this arithmetic sequence, quote that formula, remember this stuff?
Yeah.
We can change that to the term, nth term is the first, the T naught, and then n minus 1. D is 3, I think. You're planting 3 more trees, right?
Yeah.
So, of course, there are 2 trees.
Yeah.
And then this is a 3n minus 3. So if you times that by that, then it's 3n. If you times that by that, then it's negative 3, right?
Yeah.
So that turns into 3n minus 1. So this formula can be used to find the number of trees in the nth month. For example, if you have, what's T0? Plug in 0 there. Oh, hold on. Is this still working for 3 more trees? Hold on, I think I made a mistake. So that's 3n. Okay. I think I made a mistake. Yeah, it's very difficult to explain because this is T0, this is
Yeah.
T1, this is T2, this is T3, this is T4, right?
Yeah.
But then I think when we use this one, we are actually making this one as the T1.
Oh.
We made that as the T1 because
Yeah.
that's the first term, right?
Yeah.
So there's a little bit of confusion here. But anyway, the question is not about this explicit formula. So actually, if we do T0, we actually get -1. And if we get T1, we get 2. And if we do T2, then we get 5. If you plug in 3 there, then what is it equal? 3 times 3 is 9 minus 1, which is 8. So you're getting all these numbers, 2, 5, 8, right?
Yeah.
But it's just like, that's considered as T1 in this formula. So this is actually a completely different approach to this one over here. We'll come back to this later.
Okay.
But it's just about, we're not really concerned about this method because we know it's arithmetic and we can figure out a formula. We can come up with the formula for it. But we're just wondering about the recurrence relationship. And I think you remember recurrence model, right? Recurrence model is about the relationship between the next term to the previous term.
Yeah.
I'm going to just go to the bathroom quickly. All right. I want you to have a look at these choices and just take a guess. All right. I'll be right back. Okay. So when you're using these formulas here, then you know exactly what, like for example, the number of trees in a particular month. So you just need the number of months and plug, and that's represented by the n there. Okay.
Yeah.
Then you know exactly how many trees there are there. But when it comes to recurrence model, it's a little bit limited in a sense that you need to know what the number of trees were before, like in the previous month, to figure out number of trees in the next month.
Yeah.
Right? Anyway, so number 3 was pretty easy stuff, wasn't it?
Yeah.
Now, moving on to question 4. Okay, let's try the question 4 there. All right. So question 4 says, graph that shows the value of a simple interest. So simple interest, again, is geometric or arithmetic. They're saying simple interest. Isabel? Is simple interest more like geometric? You multiply by some number, or arithmetic where you keep adding by the same number? When it's a simple interest. Let's go up a little bit. So simple interest of 7% when you initially have $100. Well, 7% of $100 is 7. So just keep adding 7.
Yeah.
Right? And which is like what? Arithmetic, isn't it?
Yeah.
That's arithmetic. You're adding by the constant term. Here, if it's compound interest of 7%, then you'll keep multiplying by how much? 1.07. 1.07, that's right. So keep multiplying by 1.07 and 1.07, okay? So you see how there's a slight difference, right?
Yeah.
At first, they look the same. But from the third term, they're different. And compound interest makes more money. You can see that, right? So if, so you say simple interest investment of $1,000, earning interest of $5 per month. Okay. So it's not giving you in percentage, it's making it a lot simpler for you. It says that you're just making $5 per month, right?
Yeah.
So is that geometric or arithmetic?
Arithmetic.
Okay. Arithmetic, that's right. It's arithmetic because you keep adding by what? 5, true?
Yeah.
So if it's getting like so $5 of $5 out of 1,000. So if you do $5 out of 1,000 and then times by 100, I'm going to teach you this stuff later. It's actually earning 0.5% every month. So it's earning, so what you need to do is, if it's geometric, then you got to multiply by 1.005. Okay?
Yeah.
So what happens is, if you times 1,000 by 1.0, if it was 1.05, then it's earning what? It's earning 5%, true?
Yeah.
If it's times by 1.005, then it's earning 0.5%.
Yeah.
Okay? And you see, if you multiply that by that, then you get 1,005, right?
Yeah.
If you're adding just $5, then you just get that, right?
Yeah.
So let's compare both of them again. So so you have 1,000, and then you get 1,005, 1,000, 1,005. So this is plus 5 there. Plus 5, then how much? 1,010.
Yeah.
Plus 5, then 1,015, true?
Yeah.
So, but if you want to do 1,000 times by 1.005, then you get 1,005. And then times by 1.005 again, that's equal to 1,010.025. Make sense?
Yeah.
So do you understand the reason why this is making a bit more money than so this is times by, 1.005, and this is times 1.005, right? So do you
Yeah.
understand why this is making a bit more money than this one over here?
Yeah.
Can you describe that to me? Why? So that's 1,015. Isabel? So why is the compound making a bit more money?
I actually don't know.
Okay. So this one over here is just adding 5, right? Adding $5, and $5 is 0.5% of $1,000. Whereas when you are going from there to there, you're actually, let me ask you this. You see that 0.5% of $1,000 is $5, right?
Yeah.
So how do we do that? All you need to do is 1,000 times by 0.5 divided by 100. So that's how you convert percent into decimals. Okay.
Yeah.
So you do that. That's $5, right?
Yeah.
Now, what about, so for arithmetic, you keep adding $5, which is 0.5% of $1,000. However, what about 0.5% of $1,005? That should be a little bit more than $5, right?
Yeah.
Because the same percentage of larger sum is a bit more money than $5, right?
Yeah.
And what about, so it keeps, that's why we use the term compound interest. It gets compounded. You earn interest, and you get interest based on your interest.
Yeah.
Right? So you see, you earn 5%, so it became 0.5%, so it became 1,005. But then you are also getting, when you move from there to there, you're not getting interest. You're not only getting the interest from $1,000, you're also getting interest from that extra $5.
Yeah.
That's why you're getting a bit more money.
Yeah.
Does that make sense to you?
Yeah.
Yeah. So the idea, this idea is central to anything that you're going to do in this chapter. This chapter is pretty hard chapter, so I think we have to dedicate a bit more time on this compared to other chapters. Now, going back to this question, graph that shows the value of simple interest. So this $1,000 earning $5 every month. So that means it needs to keep going up, right? So this is not right. It means, you know, $1,000 is staying as $1,000, right?
Yeah.
This means $1,000 is going down. So your money is worth less. Here, I think the money is not going up in a steady manner.
Yeah.
The only thing that has money going up in steady manner is A. True?
Yeah.
So it's gone up by $5. So it's 1,005 and 1,010, 1,015, 1,020, 1,025, etc. You know?
Yeah.
And by the time it goes up to 10, then it'll reach up to 1,050. Okay?
Yeah.
That makes sense?
Yeah.
So let's move on. I think you heard enough explanations, so I think it's time to just do questions. I think you're ready to do questions. Let me just save this one. It's rather a bit slow. Okay, I think, hope it doesn't crash. Okay. All right. Now, question 5 and 6. Let's try question 5 and 6. So Arthur invests $2,000 with the bank. He will be paid simple interest at rate of 5.1% per annum. I want you to calculate, Isabel. I want you to calculate 5.1% of $2,000, please, using a calculator. I'll give you some clue if you're confused. It's $2,000 times by something. And that number is related to this number here. All right?
Okay.
This is what we need to do. $2,000 times by, so there are a number of ways of doing this. 5.1 divided by 100, okay? So divide by 100. We always, when there's a percent, we divide by 100 to get, so in this case, 2,000 times by that number, that's 102. So the answer is 102 here. Now, there is another way. You can just pick whatever method you like, okay?
Yeah.
If you understand that 5.1% is the same as 0.051, then you can do that also. You get 102.
Yeah.
Right? Or if you still like to keep the 5.1, you can do 5.1, and then there is a percent symbol somewhere, like that.
Yeah.
See this percent symbol?
Yeah.
So 2,000 times by 5.1%, that means what is the 5.1% of 2,000? It is 102. Okay?
Yeah.
I'm just going to say, I'm going to change this to 5.1%, okay? So if 5.1% of Australian population contracts coronavirus, how many people are they? Can you work it out? You can do it on your calculator. Okay, so you got to do 25,25,000,000, and times by, which way did you do? Did you do the division by 100 or 0.051 or 5.1%?
Percent.
Okay, so you found the percent symbol?
Yeah.
Okay, so that's 1,275,000, right?
Yeah.
Easy. Now, this guy invests $2,000, but it's a simple interest of 5.1%. And we figured out that the 5.1% of 2,000 is $102, right?
Yeah.
And because this is simple interest, this guy will be paid $102 every year.
Yeah.
Okay. There's no compound interest. He's not gonna get the interest upon the interest. He's just gonna get the $102 constantly every year. Okay. Now
Yeah.
VN is the value of Arthur's investment after n years. a recurrence model of Arthur's investment is. So we know that V naught is 2000, right? So they're all correct.
Yeah.
For A, B, C, D, all of these choices, their V naught is correct. But then
Yeah.
what's going to be the Vn plus 1 in relation to Vn? This is the value of the total money. So I'm going to just tell you this. V naught is 2000. How much is V1? V1 is the money that's worth, the worth of money after one year. Do you know how much? What's going to be the value of his investment after 1 year? It's going to get that much money, right?
Yeah.
So is it going to be $102 or $2,102?
102.
It can't be because value. This V represents the
Oh.
value of his investment.
Yeah.
Is it 102 or 2,102?
2,100.
That's right. That one there, right? Because you got to add the interest on top of the already existing, money. True? Yeah. So what's going to be V2? Another year later. Another year later. Are you working on it?
2,204.
Exactly. 2,204. So it keeps on going like that, right? It keeps on increasing by how much? $102, right? So this is like an arithmetic sequence, Keep adding 102, 102, So that's 2,306, etc. So what is the relationship between the previous year's value to the next year's value?
Plus 102.
Plus 102. So must be 102 plus the previous year's value, right?
Yeah.
That's the new year's value. So the answer is D, true?
Yeah.
Very good. Number 6, an interest rate of 4.6% per annum. Per annum means per year, okay?
Yeah.
Is the same as an interest of how much per quarter, per fortnight, per month, per week, all right? So we're going to do all of them, okay? So 4.6% per year. And we're going to figure out the per quarter, per fortnight, per month, and per week. How many quarters are there in a year? A quarter is 3 months.
Yeah.
So there are 4 quarters in a year. How many weeks are there in a year?
52.
52, that's right. And how many months are there in a year? 12. How many fortnights are there in a year?
26.
26, that's right. So if you want to calculate the so if you're getting 4.6% per year, that's actually the same as just divide that by 4. Then you get this, divide by 26, divide by 12, divide by 52. Then you get this one, okay?
Yeah.
So just 4.6 divided by 4, and that's equal to 1.15. Does that make sense to you?
Yeah.
4.6 divided by 26. That's equal to 0.177. 0.177. And 4.6 divided by 12. That's equal to 0.383%.
Yeah.
This is also percent. And yeah, the other one is 4.6 divided by 52. So that's equal to 0.0885. 0.0885%. Remember, these are with percentages, right? So when it comes to actually calculating their true decimals, this is actually, that becomes a multiplication by 0.046, understand?
Yeah. Yeah.
And this is 0.115. This is how much? 0.00. You know, that spot is 1%. The spot, the decimal place for 1%, right?
Yeah.
But this is like, that's why you have, if you have 1.15%, that's why you have 0.0115. You know, although you can still use, and when you have 4.6% in the calculator, you can still use that symbol.
Yeah.
But you do need to know how to convert them into decimals. Okay?
Yeah.
So can you tell me, so if 4.6 is 0.046, 1.15 is 0.0115, what is 0.177% in decimals? I'll give you some time. You can just figure out. Okay, so that's multiplication by that, 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 and that, okay? So if you put 2 zeros there also, then you get 0.00177, 0.00177, understand?
Yeah.
Just have to put 2 more zeros. Put 2 more zeros here, it'll be 0.00383. Make sense?
Yeah.
And what about this one then?
0.000885.
So it'll be 0.000, right? 0.000885. Understand?
Yeah.
Now, anyway, going back to this question, which one is right? Per quarter, 1.15. I think that's correct.
Yeah.
Right? Per fortnight, is that right? Per fortnight, 0. Per fortnight is 0.177. Well, not quite 0. If you round it up, it's actually 0.18, right?
Yeah.
So that, I think that's also sort of right, but not quite. And per month is 0.383, right? So that's not 0.35, so that's wrong.
No.
Per week, it's 0.0885, so that's wrong. And E is definitely wrong because, you know, they don't really tell you. They're not talking about, you know, they haven't mentioned to you what the original figure is, how much you have. So, you know, it's not the same as, you know, certain, you know, having this in dollar figure, that's completely wrong.
Yeah.
So, you know, it depends on what the original money is. Or if you have $1,000,
Yeah.
then it'll be $46, 4.6%, you know?
Yeah.
And if you have $10,000, then it'll be $460, right?
Yeah.
So it just depends on how much money you have. The question doesn't mention to you what the original, you know, how much money you have. So you don't know how much that interest will be. So that's completely wrong. So I will just go for A. Okay.
Yeah.
What time do we finish?
6:30, I think.
6:30. Okay, so it's time to finish here. I'm just gonna talk to you about one. Just tell you one more thing.
Yeah.
So you see, so you now learned how to go from there to there, right?
Yeah.
And you also need to know how to just add 1 there. So if you add 1 there, then what do you get? 1.046, right?
Yeah.
1.0115, true?
Yeah.
And this would be 1.00177. This is 1.00383. 1.0000885. Okay?
Yeah.
So what's the difference between this one and this one? Again, so if I have if I have $100, and if I just want to know the interest, then I multiply this by 0.046.
Yeah.
Okay. If I want to know the interest plus the principal,
Yeah.
is it principal or principal?
Principal.
Is it? Okay. So then you multiply by 1.046. Okay. Notice the difference?
Yeah.
So if you multiply 100 by 0.046, then you get $4.6, of course. Or if you just multiply by, 4.6%, doesn't matter which way you do it, you get that. Okay.
Yeah.
But so that's just $4.6. But if you multiply by that, then you get $104.6. Okay.
Yeah.
All good. So we'll
Yeah.
call it a day here. I think it might be if there is like too much work, like too many assignment and homework based on chapter 5,